In this episode,
without a doubt, we are breaking new ground. We are pushing the bounds of engineering.
a new city district rises from the Arabian Sea, crowned by the world's biggest observation wheel.
Things that 10 or 20 years ago people would have felt is just not possible. It is possible now. It's really very exciting.
And the pioneering historic innovations.
Oh man, this is amazing!
What a beautiful, impressive and powerful bit of kit.
That make the impossible possible. Dubai, in the United Arab Emirates, is home to some of the most innovative engineering on the planet, where each new build must push the boundaries of what's possible in order to stand out from the crowd. One man who knows what it takes to make a mark on this ever-evolving city is Mohammed Al-Mula.
Dubai has been able to prove that there is no limit to your freedom of thinking. It's important that we keep pushing the boundaries of engineering across every project we do. Dubai known to be bringing the best in class in various aspects, from the tallest towers to the biggest airport. I'm sure Dubai in the next few months will be another mega project that will be announced. Once you have a dream, people will get together and just help you to achieve that dream.
This desert city is determined to keep creating the most spectacular structures in the world. But Dubai is quickly running out of its coveted waterfront locations. So engineers now have to think outside the box.
The coastline in Dubai has a limited stretch. You have certain type of tourists who look for beach, so we must make sure we have enough beaches. We must extend the coastline. It's very important for our survival to move forward in a very competitive landscape.
Creating land where there once was none is a massive undertaking. And engineers in Dubai aren't just creating land. They're thinking much bigger and creating a whole new island. This is Blue Waters. Constructed from 28.3 million cubic feet of rock and 141.3 million cubic feet of sand, Blue Waters Island covers an area larger than 12 New York City blocks and will be populated by a combination of residential towers, shops, and five-star hotels. Its crowning glory is the Ain Dubai, an observation wheel that stands an unprecedented 820 feet tall.
When you arrive, you'll see the wheel. It will be a moment, a wow moment. I'm sure everybody's jaw will literally drop and they'll just stand there in awe.
But this multi-million-dollar project poses huge engineering challenges. Is it possible to create land where there is nothing but sea?
Blue Waters Island is a very challenging project for us because desert sand is not suitable for island construction.
How do you make it strong enough to support tower blocks and a mega structure?
Loose sand, it's very limited in the load that it can support. Typically maybe 10 to 20% of what you would expect on traditionally formed ground.
And how do you build a wheel that towers over every other wheel ever constructed?
These cables have to be very strong, but if we put all the tension in the bottom, we would just buckle the rim.
Blue Water Island, we keep on pushing our boundaries.
This is the most challenging engineering project happening in the world at the moment.
It's going to take a top-notch team of engineers to pull it all off.
Okay, let's go.
Civil engineer Cone Sweers is overseeing island construction.
It's a good day for surveying today, I think.
Perfect day.
To find the perfect location, the team needs to uncover what lies beneath.
We start the island with what we call an in-survey, where we map the seafloor, where the future island will be, and that's basically our starting point.
Sonar and GPS allow Cohn and the team to precisely map the bottom of the sea.
Oh, you see there popping up on the screen. Yeah, perfect. So here now it is 7 meters, eh?
Yeah, exactly. It's between 7 to 9.
Yeah. Based on that, we can calculate up till the design level of the island.
Building Blue Waters will require a staggering 141 million cubic feet of sand. And despite being located in the world's 5th largest desert, finding the right sand is far from easy.
Desert sand is not suitable for building an island. The sand particles of desert sand are very round, and this is not good for the interlocking between the individual grains. It's like you have a jar with all of the same marbles.
Engineers have to use sand from below the sea.
We use marine sand. Marine sand is very suitable for construction works because it is much more angular. And marine sand has a lot of particles of different gradings. And it is coarser, so it settles much more easier.
But with the marine sand sites 30 nautical miles away, engineers are facing a giant challenge.
Instead of bringing sand by road transport to the location, we have to find other means to bring the material from sea to the location of the island.
There is a solution across the world. Miami Beach in Florida. Today, it's one of the most glamorous and prestigious coastal resorts on the planet. But just over 100 years ago, it was a desolate, swampy wilderness. Its success is all thanks to the vision of one man, Carl Fisher. He came up with a genius plan to convert this marshland into what he called the prettiest little city in the world. Mechanical engineer Dan Dickrell is on a mission to find out just how he did it.
Oh man, this is amazing! What a unique experience driving an airboat in the Everglades. Yeah, this is the natural Florida.
In the early 20th century, Miami's coast was a very different place than it is today.
Oh yeah, I'm gonna go a little bit more up ahead. There's a good spot right up there. Perfect. Okay, so this is what Florida used to look like. The land that Fisher bought would have been very, very close to this. Oh, it's super soft. There's mud and silt in there. From an engineering perspective, there's nothing that you can build a solid foundation upon.
But despite the makeup of the South Florida swamps, Fisher was undeterred. He believed a solution could be found through engineering.
So this vessel is a hydraulically powered cutter suction dredger. And it's the same type of thing that Fisher believed he could use to realize his vision. Now I'm going to give these controls a go and see how it functions. On the end of this large boom, we can see gnarly looking cutter wheel. I can move it up and down. I can move it left, and I can move it right, all right? If I turn this knob here, we transmit power to the cutter head. So now this cutter head's gonna rotate. As I drop it down, I'm gonna engage the bottom. Now what's gonna end up happening is I'm gonna start removing material. And as that material is removed, it's being transported through that orange hose. That's a discharge hose. That discharge hose is connected to a hydraulic pump, which sucks the water and solid material through and transports it a long distance away to trucks or back on shore.
For Fisher, cutter suction dredging offered the perfect solution. The trees and shrubs could be cut away, and the dredged materials used to create an island, just like engineers in Dubai want to do. Between 1914 and 1928, Fisher's dream began to take shape, much to the amazement of those who had doubted his plans.
And this is the end result of Fisher's ambition, Miami Beach. So standing here looking out from an engineer's perspective, it's an outrageous idea to imagine Fisher took a swampy wasteland and turned it into one of the premier beaches of the world. Talk about making the impossible possible.
Back in Dubai, engineers are pushing Fisher's idea even further. For Blue Waters Island, they'll need to reclaim over 140 million cubic feet of sand from the depths of the Arabian Gulf.
You can compare that to 2,000 truckloads of sand each day, 7 days a week, for 5 to 6 months long. So we mobilize dredges from around the world.
To achieve this Herculean feat, the team will use a supersized version of the vessels that were once used to transform the Florida swamps. And they will also need to put some modern-day technology to the test in order to turn this island dream into a reality. In the Arabian Gulf, off the coast of Dubai, an incredible project is underway. Engineers are collecting what will be the foundation of Blue Waters, a completely man-made island built from millions of tons of sand from the ocean floor. To collect all of this sand, they will use the same vessels that created Miami Beach in the early 20th century, only much bigger.
We used cutter suction dredges. These dredged the harder material that we encountered. Then we used trailing suction hopper dredges. Basically, it is a vessel with a big vacuum cleaner on the side. They suck up a mixture of sand and water from the sea bottom.
Gathering the sand is one thing, but engineers now face another challenge. Once the shape of the island has been outlined using rock and protective textiles, they'll need a way to deposit such enormous volumes of sand.
In the first phase of building an island, when there's still sufficient water depth, then we discharge the material by opening the bottom doors of the vessels.
But as the island grows, engineers must turn to other ways of depositing the sand.
One is what we call rainbowing. You will see a rainbow of water sand flying through the air straight to the location where you want it to be. We use that technique at Blue Waters quite a lot.
When the mighty vessel can't get close to the island, engineers have another trick up their sleeve.
You see on the bow of the vessel this round cylinder construction. From there it will connect to a floating pipeline, and then it will pump the material through the floating pipeline. We can pump, if necessary, a few kilometers away into a series of shore pipelines in the location where we want the material to be. These kind of vessels are crucial. They basically do the hard work. We come and there's nothing, and we leave and there is an island. So yeah, it's tremendous.
But before they can begin to construct this landmark, engineers face another obstacle.
We inherit a site that contains very, very loose material, and you get a lot of movement, and that can cause a lot of damage to a building and can make it unsafe.
They'll need to transform a giant pile of sand into a foundation strong enough to support an entire city district.
The scale of the buildings can often be really daunting. Is it buildable? Can it be built? Has it been done before?
David Murray is a leading engineer involved in this seemingly impossible transformation.
We inherit a site that contains very, very loose material. It's really due to the nature of how the island has been formed. The sand is pumped and sprayed into position, so there's no real compaction process. And what this means is that the sand has got a very, very low strength. When a structure is built on top of that sand in its loose state, it's prone to substantial deformation and settlement, because as the weight of the building pushes it down, you get a lot of movement, and that can cause a lot of damage to a building and can make it unsafe. So it needs further treatment to provide extra strength and stiffness.
The answer to this problem just might lie with the innovators of the past. Andrew Steele is in the British Midlands, putting his back into some good old-fashioned manual labor.
Well, that's a nice big pile of sand. Let's try flattening it out. Oh. Here goes nothing.
In the early days of road building, heavy cast iron rollers were a typical tool for compacting foundations.
Well, this really isn't a very practical method.
Making it a slow and expensive business. As the importance of a modernized road network grew, so did the need to get it built quickly.
You can see why they wanted to try and find a more efficient, faster and cheaper way of flattening out sand than this, because this is ridiculous.
Luckily for Andrew,
now this is more like it.
in 1867, two engineers came up with a solution.
This is an absolutely incredible machine. Look at her roll.
Pioneered by Thomas Aveling and Richard Porter, the steamroller marked a watershed moment for heavy industry. And this 125-year-old example is one of the oldest surviving rollers on the planet.
This thing's just a beast. Look at the size of these cast iron wheels and the power of the steam that we're using to get this thing rumbling down the road. Oh, I wish it had power steering, though.
Weighing in at an earth-shaking 11 tons, this monster machine is a powerhouse when it comes to compaction.
Right, let's see if this thing can do any better. Much more fun. What a beautiful, impressive and powerful bit of kit. Well, that is much better than my shoddy attempt. Not only did we manage to do it in a single pass and cover a lot more area than I managed manually, but if you get down close, you can see this sand is much more compact and firm than I could manage with that little manual roller. Looking at this, it's obvious why that machine was such a hit.
But there was an unintended side effect to these early steamrollers, one that could be important to the engineers of Blue Waters Island. In Dubai, engineers have collected and deposited massive amounts of sand to create blue waters. But before this man-made island can be built on, the loose sand will need to be compacted to ensure a strong foundation. It turns out that the earliest version of the steamroller, built over a century ago, might have exactly what the team in Dubai needs.
Because they were often driven in a very low gear with high revs, and engineers started to notice that this front roller here would be vibrating. Now, this actually has a benefit when it comes to compacting a road surface. And so I'm going to show you a little demo to try and explain why that is. So what I've got here is a plastic cup, a little bit of breakfast cereal here. And I'm just going to pour the breakfast cereal in. There we go. And now to simulate that vibration, I've just got a bit more of a modern tool, this electric drill. So if I just apply a little bit of vibration, oh wow, that worked very quickly. You can see those little grains of rice in there. They're just moving around pretty much at random. And what that means is that they're settling down to their optimal positions.
As the vibrations cause the grains to move, they begin to settle closer together, closing up the air pockets and improving compaction.
Having noticed this, engineers building modern versions of this steamroller would actually intentionally build in that vibration to try and take advantage of this effect.
The introduction of the steamroller went on to revolutionize road building in Britain and beyond.
This beautiful machine was fundamental to the past and still continues to shape our future.
Engineers in Dubai are using an arsenal of heavyweight machinery to shore up their new island. Among them is a descendant of Aveling & Porter's traditional steamroller.
So this is a 27-ton vibrating roller. Now you can feel actually the effect on the ground. It's shaking beneath our feet quite dramatically. As it rolls, it also vibrates. So it has a very good compacting effect. You can really feel it now, and so it gives you an idea of how much shaking and vibration of the ground is happening. This machine is rolled over the surface of the sand, and what it does is it densifies the sand to give a very, very strong capping layer.
Vibrating rollers can compress the top 6 feet, but the challenge here goes much deeper. To fully compact the millions of cubic feet of the island's sand, engineers need an extra tactic.
In order to overcome the various risks associated with loose soils, we undertake a ground improvement process, which in this part of the world has become very successful, and it's a process called vibrocompaction. Okay, take it up.
It's a technique made possible thanks to even more supersized machinery.
So we're now looking at a typical poker assembly. The majority of this will be underground during the compaction process. You can just get a sense of the scale of this when you look up. We're talking about 4 or 5-story building in terms of the depth of improvement that goes below the ground.
Vibrocompaction begins with the poker penetrating the ground to the required depth. As the poker vibrates, it's raised up in stages, causing the sand to compact around it. The crater that develops on the surface is backfilled, then re-leveled and finished using the vibrating roller.
The great thing about this is it's a very quick way of compacting the ground, what we call an accelerated compaction. We don't wait for hundreds of thousands of years, we do it instantly.
But with plans for multiple towers and a massive megastructure, engineers will need to further bolster Blue Water's island.
If you're building a very lightweight building, 2 to 3 stories, in general, yes, you can build off ground like this. But when we're talking about taller structures and megastructures, this material on its own won't have sufficient capacity to support the ground. It does give a contribution, but not the entire support to the structure.
Huge concrete piles will help to underpin the biggest builds.
Those piles have to be anchored deep down into the rock. They don't just sit on the surface of the rock, they actually extend 10, 15, 20 meters down into the rock. And there's a friction between the pile and the rock, which stops it from pulling out.
Now, with the ground compacted and foundations deployed, engineers can finally begin to build. Residential towers, luxury hotels, and retail parks all rise up to take their place in the city's crowded skyline. But the biggest challenge of all still remains: how to construct the planet's largest observation wheel. Off the coast of Dubai, engineers have successfully laid the foundation for Blue Waters Island. With several luxury hotels, shops, and restaurants in place, they're now gearing up for their final challenge, the Ain Dubai, the world's tallest Ferris wheel.
It's like Piccadilly Circus round here. Can I go around here, guys?
Project manager Piers Saidi is the man overseeing this record-breaking build.
There are obviously other observation wheels around the world, but we're about 50% bigger than the current biggest.
Once complete, the Ain Dubai is set to rise more than 820 feet above the Arabian coast. It will be almost double the size of the giant London Eye, making it comfortably the largest wheel on the planet. And it will set a world record that some believe will never be broken. 48 specially designed pods made from aviation-grade glass will carry 1,900 passengers. But supporting this massive structure requires a framework on an equally epic scale.
So the main components of the structure, we have 4 legs, 900 tons each, 125 meters long.
With the streets of Dubai packed with traffic, transporting this giant component by road would be impossible.
Really, transportation was only going to ever be by water, so because we're on an island, we bring them in by barge.
Each giant leg weighs more than 5 747 jumbo jets. But on a build of this size, the problems just keep getting bigger.
The heaviest part is the hub and spindle, which connects all the legs together and carries the 6,500 ton weight of the wheel.
Raising this nearly 2,000 ton component to the required 413-foot height calls for more problem solving.
So we can put a block on that top platform, pick it up and lower it off. Otherwise we can't get a crane to it.
Yeah.
The only way to conquer this supersized challenge is to use supersized technology.
We lift them off with 2 of the largest cranes in the world. $3,000-ton capacity units.
Bump the touch to the right.
Working at about 98% of their safe working capacity.
Stick boom down, 20 centimeters or so. You gotta go like a hair to the left.
The biggest tandem lift, and certainly the highest tandem lift that's been done before.
And keep coming down, looks good. And stop.
Engineer Darren Brook has special clearance to climb through one of the mighty legs to the spindle itself.
We've just entered leg 1. The legs are inclined at about 16 degrees, so this lift also then travels up the profile of the leg and had to be specially designed to meet that angle. So where we are now is in the middle of the spindle. The spindle is approximately 135 meters in the air. As you can see, it's a vast space, 6 meters in diameter. It connects the 4 legs. This space is big enough to fit 2 buses in. Running around the outside of that, and we can just sort of see through these hatches here, is the hub.
The gigantic rotating wheel will eventually be attached to this unit.
The hub is actually the moving part and actually contains all of the bearings that then run over the spindle. The hub itself, that's really transferring all of that load into the spindle and then to the legs and then back down to the ground and the foundations.
It's an impressive achievement. But on a project of this size, there's always another challenge that lies ahead for engineers.
With a wheel of this scale, I think the biggest challenge is trying to foresee the unexpected before it happens.
To achieve this monumental undertaking, Piers and his team will be pushed to the limits.
It's a huge task and a huge challenge to build something and design something of this size.
Blue waters in Dubai. A brand new man-made island risen from the sea. Complete with residential towers, luxury hotels, and retail shops. It's soon to be dominated by a colossal structure, the world's largest observation wheel. With the enormous legs, hub, and spindle in position, leading engineer Piers Saidi and his team must now solve a new problem: how to construct the wheel itself.
The rim is built in 8 sections, lifted off the barge, welded together, launched with a special push-pull system.
Supported by massive steel wagon wheel-like spokes spanning the radius, engineers weld one section of rim to another, push and pull it around, then weld on the next section until the circumference is complete, revealing the fully assembled wheel for the very first time.
I think it is a particularly beautiful wheel. We've had lots of things for the designers and the erectors to overcome, and we've managed it.
But in order to complete this world-class wheel, one final challenge stands in the engineer's way. The wheel must support itself without the aid of the 8 large steel-framed spokes.
It was part of the brief that this had to be aesthetically beautiful, had to take it the next step beyond some of the other wheels to create a very light-looking structure. So we need to keep the weight down, but keep the strength.
To keep the wheel strong, stable, and yet still lightweight, engineers will need to draw on an innovation from the past.
This is really cool to be here and just can't wait to get up.
Mechanical engineer Melanie Todt is in Vienna to take a unique look at an epic engineering feat.
Let's go.
The Wiener Riesenrad, the oldest Ferris wheel on Earth.
This is so amazing to see the whole structure so close, and we can even see the wheel moving.
At almost 213 feet, it was once the largest.
I'm touching one piece of history here. This wheel was actually built 120 years ago. This is really amazing.
But it wasn't the first. In 1893, American engineer George Washington Gale Ferris Jr. designed the first ever fully circular large-scale observation wheel. The Wiener Riesenrad was built on similar principles to Ferris's revolutionary wheel.
When George Ferris came up with this idea, people thought he's crazy because no one could believe that something that thin, that slender, could carry its own weight. They did not even think that such a wheel can be built.
Ferris was determined to prove them wrong. But just like the engineers in Dubai, he faced a huge problem.
Ferris needed to find a lightweight design that can carry its own weight. To realize this construction, George Ferris used a principle that is called pretensioning, and this is a principle that allows such thin constructions to carry much more load than without the pretensioning. It's the same principle as the wheel of a bike.
Old small fairground wheels used large heavy beams to support their outer rim, like a wagon wheel. But Ferris realized that, like the spokes on a modern bicycle, he could use relatively thin wire or cable to make his wheel strong. These cables would have virtually no strength in compression, but as long as they were tightly and evenly tensioned, they would be more than up to the job.
That's fascinating to see actually how the cables are mounted to the spindle.
To truly experience Ferris's innovation for herself, Melanie is going to take it for a spin.
Danke. It's so smooth. George Ferris actually reinvented the wheel. He brought lightweight design to new limits. Due to his achievements, it's now possible that we have this kind of huge observation wheels.
More than a century later, engineers in Dubai will take Ferris's idea to even greater heights. On Blue Waters Island, engineers are attempting a record-breaking feat. Construction has begun on the Ain Dubai, the world's largest observation wheel.
The concept was to create something that was amazing and just awe-inspiring. To create a structure that did look lightweight, but keep the strength.
By using pre-tensioning, the wheel's temporary rim supports can be removed, leaving only the slender cables to carry the load.
And to do that, we've used some very high-strength steel. These cables can take over 300 tons of load.
Despite using super-strength cables, engineers still rely on basic principles.
You can actually liken this wheel to a bike wheel. You can't actually tension all of them at once at one area because it'll just buckle the rim. And it's exactly the same challenge we face here on a wheel of this diameter.
Huge hydraulic jacks tension 24 cables at a time. The wheel is then turned, and the process continues until all 192 cables are tightened. At 100% tension, each cable can hold more than 600,000 pounds, the equivalent of 50 African elephants. It's another example of the innovative solutions that make up this groundbreaking wheel. A structure so massive that it dwarfs the competition.
So we're 135 meters in the air, and we're looking out over a beautiful Dubai landscape. We get a fantastic view from up here. We're not just making the largest wheel, we're going up by orders of magnitude in terms of the largest wheel. It's a phenomenal project, it's a phenomenal undertaking.
It's a feat that all involved can be proud of.
In my opinion, this is the most challenging engineering project happening in the world at the moment. And personally, I've been very proud to be involved since the beginning.
By learning from the great pioneers of the past, adapting, upscaling, and overcoming huge challenges.
It always pushes me to the boundaries. The nice thing about it is that you have created something that will be there for the next 50 or 100 years. And that's something that gives incredible satisfaction.
Engineers have continued to push the boundaries. In a city where the sky truly is the limit, they've succeeded in making the impossible possible.
We went with the assumptions to break every norm, every parameters, till we prove it doesn't work. And guess what? Working with the best in the world, we've been able to again put another mega project up and running, and we are proud of that achievement, another achievement for Dubai.